Welcome back, everyone. This is actually our second factoring difference of squares videos. We've got some more examples here. These are not our beginner level examples, so you may want to check out our intro video to factoring difference of squares. You can find it in our algebra playlist right before this. So here we're actually factoring some slightly more difficult ones. Some of them still not too bad. A couple of them may be a little tricky, but here factoring 9x squared minus y squared. Remember, difference of squares, the idea is this term is a perfect square, so is the second one. We have two terms and you have subtract in the middle, difference of squares. So this first one here, we see 9x squared hopefully as 3x times itself. We see y squared hopefully as y times itself with minus in between. So this factors as a difference of squares. This will factor into conjugate factors with the same terms. So we will get 3x as the first term, and we will get y as the second term in each factor. One factor will have add, and one factor will have subtract, just as described in our intro video about how they factor into conjugates. Remember, that means that one will be addition and one will be subtraction. Over here, this is a longer perfect square, but everything in this term is a perfect square. So this is really 5xy times itself. You can just take each part of the term and think about what is the square root of that. And then here, this is really just 2 times itself with subtract in between. So our factors will start with 5xy, and our factors will end with 2, and one will have addition and one will have subtraction. Looking at some more examples here, we've got x to the fourth minus 1. So we want to see x to the fourth hopefully as x squared times itself. In other words, x squared squared. The 1 we should just see as 1 times itself. That is 1 squared, and subtract between. So my conjugates will have x squared and 1 in them. So I will have a 1 factor that has x squared plus 1. And I will have another factor that has x squared minus 1. Now, looking here, you may notice that one of these factors is still a difference of squares. This one is a sum of squares. We will introduce in one of our upcoming videos very shortly that a sum of squares does not factor. Let's focus on this difference of squares here. So this one, we want to see this as x times x, and we want to see this as 1 times 1. So we will leave the sum of squares, the x squared plus 1 will stay. The difference of squares should factor into conjugates again. So this is x times x, so I should have x in each factor. This is 1 times 1, so I should have 1 in each factor. 1 will be add, and 1 will be subtract. So we had the x to the 4 minus 1 as a difference of squares originally, factored into conjugates, and one of those conjugates was itself a difference of squares, giving us 2 separate factors there. So we actually get 3 factors there once we break that down a second time. Let's look here at a similar thing. This here is a perfect square. This is 4 times 4 for the 16, and this is x squared times x squared for the x to the 4. This here, 81, is 9 times 9, so that's 9 squared. We have subtract in the middle, so this is a difference of squares. I have 4x squared as one term. I have 9 as another term, so one will be add, and the other will be subtract. So we have 4x squared plus 9, 4x squared minus 9. This is a sum of squares, which does not factor, but you may notice again that this second factor is still a difference of squares. 4x squared here, this is 2x times 2x, and this is 3 times 3. So we keep the sum of squares, which does not factor. And this becomes 2 separate factors, 2x plus 3, and 2x minus 3. All right, last examples here in the video. We have x to the 4 minus y to the 4. So we first see this as x squared times itself, and we see this as y squared times itself. So I get x squared plus y squared as one of the factors, and I get x squared minus y squared as one of the factors. Again, you will notice this is a sum of squares, which does not factor. This is a difference of squares, so we will continue. Keep the sum of squares with the difference of squares factoring again. So this is x times x, this is y times y, so we'll get x plus y and x minus y. We'll do a similar thing here, except we have our variable is only in the back now. We don't have any variables in the front. 256 is a perfect square. This is actually 16 times 16, so that's 16 squared. This is t squared times itself, so this is t squared squared. Let's subtract in between. So my factors should have 16 and t squared in them. I get 16 plus t squared, 16 minus t squared. Sum of squares here again will stay, does not factor further, but this again is a difference of squares. This is 4 times 4, and this is t times t, so I should get 4 plus t and 4 minus t. Okay, several examples there, some of them multiple difference of squares within one problem. Hopefully you're starting to see them. Good luck on your difference of squares.